there's all these acronyms that have EV at the end of it. They're all electric vehicles because they all have electric motors. But they are different in that battery electric vehicles do not have an internal combustion engine. Plug-in hybrid electric vehicles, you can plug in and charge the battery directly, so they do take a power source, but they also take gasoline, so oil. You have the hybrid electric vehicle, which is the Prius, and they actually don't take a plug, and you have to fill them up with gasoline. And then you have the fuel cell electric, which is a hydrogen vehicle, but it's also an electric motor. So when we talk about electric vehicles, we talk about all of those, but most of the regulation really focus on plug-in electric vehicles, or PEV, which is what most people are focused on when we try to maximize electric mileage, is people who can plug into an electric grid, charge up their vehicles, and use it for transportation, and then some cool technologies that come later. From 2008, we had 4 vehicles available. Not a lot of people purchased electric vehicles at the time. And this has grown now to 65 electric vehicles available in the United States. And this is a little deceptive because in California, due to your regulations, you have a lot of vehicles available. And you probably are all very familiar with a number of different vehicles. But really, in other areas of the country, there might only be 10. So when you see the uptick in California, a lot of it is because you have a higher number of electric vehicles that do different things and that you can identify yourself with as a consumer. And then really, EV technology is really all about the battery. And so the cost of the battery, price per kilowatt hour, has been going down significantly, very rapidly since 2010 to 2018. A lot of it is because of industrial capacity and improvements in the manufacturing of it. So it's not necessarily brand new technology, but our ability to scale up production. And so a lot of the experts think that when we hit $100 per kilowatt hour, that's when you get a price parity with an electric internal combustion engine vehicle of the same class. Now, when I say price parity, that's to start up, right? The price of the vehicle when you purchase it. All electric vehicles right now are cheaper when you consider total cost of ownership. And so if you really, if you make the calculation as a user, which commercial fleets could do, then you're actually saving a lot of money by going electric. Now, people don't because of different constraints, but in terms of economy, it's really the best choice. This is the global growth of electric vehicles across the world, and here you see that China has had a lot of growth in recent years, and it's based on very aggressive policy. So policy matters. A lot of the growth that I'm going to show you soon in the United States has come from California, because policy matters. It's what's driving a lot of the business here, but you can see right now world share is about 2.2% of new vehicle sales. That doesn't mean there's 2.2% of the entire fleet. It just means that new sales, there's about 2.2% of vehicles, of all new vehicles sold are electric. That's actually very, very small. In terms of how rapidly you transition, it's going to be a very long transition because vehicles take 7 to 14 years to really rotate. And so if you today did not buy an electric vehicle, that vehicle is going to be in the marketplace for a very long time, and it's going to exist for a very long time. Now here in the United States, we've had similar growth, and you can see it's the upward trajectory. There was a significant jump in 2018, and that was due to the delivery of the Tesla Model 3. And so right now it's sort of slowing down again, and it's going to take the traditional curve here probably going out. But again, we're about 2.2%, so the US is right in the middle of world adoption. And here I just thought it'd be interesting because we're in California, so you can see the difference between California uptake versus the rest of the US. So the US, sort of an average going up to 1-2%. Here in California, all of a sudden, you jump to 7.8% in 2018. So it's really starting to be the first state that is sort of going into mass market. And so it's definitely going to be the first state that experiences this type of mass market deployment. So it's impressive, but it's not enough. And so one of the things I care the most about is about climate change. And so if you think about the deep decarbonization pathways that you have here in the United States, it's not nearly enough just simply by the market trends. And so in the rule of thumb, we have to estimate that by 2030, 100% of electric vehicles, of all vehicles sold must be electric so that we can meet Paris Agreement targets, climate stabilization targets, and stay under 2 degrees, right? So even though we're having very impressive growth in the market in terms of market growth of any technology, it's impressive, it's not nearly enough what it takes to beat climate change. And so if we turn into really the policy, if you look at all of automaker announcements of where they think their sales are going to be on electric vehicles by 2025, they're actually beating all of the regulations that are out there already, the minimum amount, and not even all the adopted but strongest proposals out there. So some haven't even been adopted. So Bloomberg New Energy Finance only takes into account policies that have been enacted by law. So they do another scenario in their analysis where they say, if all these announcements and goals that are out there were actually turned into law, then the jump might be a lot higher. You might go even to 70% of new electric vehicles by 2040. So they have a scenario for that, but it requires that step of policy. So policy matters here, and that's what I'm trying to say, and it seems to be lagging behind even what the automakers are doing. Okay, and so to the interesting part is charging infrastructure. So I really like this infographic from the You to Drive Electric campaign. It is about the Society of Automotive Engineers levels of charging. So we have level 1, we have level 2, and we have DC fast charge. Many people think it's level 3, but it's not, because it's a completely different animal. So level 1 and level 2 is AC. So 120 volts, the regular outlet that you plug in, or 208, 240, which is really a dryer. And so that is the difference. Those can exist in your home very easily and safely. When you start talking about 208 or 480, and you start talking about high amperage and up to, right now it's 50 kilowatts of DC fast charge, but Electrify America has announced that they're going to go up to 350 kilowatts. Now you're talking about a different animal. You're talking about different demand charges. You're talking about, safety concerns. How big does that wire need to be to not heat up and blow up and be safe for charging? And so recently I saw that Electrify America is discontinuing their 150 to 350 for the moment due to safety concerns. So there is an infrastructure band, sort of a limit on how fast we can charge vehicles. It can't just keep going up forever, because we have real electrical barriers of electrical grid. But ultimately you're trying to get to a point where you charge fairly quickly. You still probably need to charge 20 to 30 minutes. So think about that. How does that change our patterns? Instead of stopping by a gas station for 10 minutes or 5 minutes, you now have to figure out what to do with yourself for 30 minutes if you do a quick charge. So where are these stations going to be located? A place you're going to have lunch, a place you're going to shop. So it's going to become a better retail experience in the future if you're using quick charging. Now most people are probably not going to use that option. They're going to use home charging for the most part. But we know consumers, right? Why are there 4 charging stations in one single corner, right? We want convenience. So as you start to enter into mass market, you can imagine that there is going to be a space for 30-minute retail activities that people are going to be like, I'm just going to stop by and have a coffee, do my grocery shopping. What is the thing that people are going to do? Because it's just as convenient as just plugging in at home, or I just want to top off. There's a lot to think about how we're going to behave with the options that electric vehicles are giving us. That's probably the biggest question in my mind, or the biggest challenge that we have in predicting the future, right? It's not likely to be a one-to-one replacement, and we're not going to behave the same way when we have electric vehicle technology. So, charging infrastructure. It's a crowded slide because it's a crowded space. And to me, it's a little bit like the Wild West. All of these infrastructure companies are trying different models. None of them is making revenue yet. A lot of them are sort of making a profit yet, right? They're making revenue, they're not making a profit. And so, but they all have different ways that they think this charging infrastructure is going to be supported. Because really, you can't pay right now for the infrastructure up front and make money on the sale of it, right? And a lot of it has to do with electric grid sort of systems that I won't go into right now. But looking at the different charging infrastructure, retail and work charging, these are companies that are focusing on the host. So you focus on someone that will be able to purchase the infrastructure, and they think of themselves as network operators, right? They don't own the charging infrastructure. Somebody else has to own it, either the workplace or Walmart or someone else owns the infrastructure, and then they operate it at a profit. That's how ChargePoint thinks of themselves, and EVgo has done a number of sort of reinventioning. We have these other models that are very interesting. Volta is betting that they can do media sales, so they can have a media revenue in a charging infrastructure, but that means you have to locate in those special places, right? High traffic areas, retail, and so is that really going to serve the needs of everyone? Is that the right location? Is it going to be equitable? And then Shell has actually bought Green Lots, and so they've now putting these stations, quick recharge, into their Shell gas stations, and they're thinking themselves as an energy provider and providing that experience of the gas station model. And then you think about Shell really has been one of the companies that has gone through that like convenience store model across the world. So they've really built out that concept of retail. And so you can imagine now this is an opportunity for them to grow that line of business, like I was saying, 20 to 30 minutes charging, and have a captive audience, not to just go in and buy, chips and a Diet Coke, but now what are you going to buy if you have 20 to 30 minutes, right? And so that retail experience of the convenience store might change in the future. It could become a really interesting revenue model for energy companies.